Hello, hope you are doing well today. I'm making another video to help you out with the next lesson of Chapter 12. It is 12-7 today, and you are assigned to read pages 793 through 796. And remember, if you haven't read those yet, please go back and read those. There are some important vocab words that you need to know for today's lesson. And the assignment is on page 798. It is numbers 15 through 31 odd. Remember to check your odd answers in the back of the book, and that will help you figure out if you're on the right track. And tomorrow there's an Alex assignment over this, so really make sure you're checking those answers and not just copying down those answers. Okay. So for today, you need to know some specific vocab words, and so the big ones are independent and dependent events. And if you have an independent event, that means that the events are separate. One does not count on the other. One does not affect the other, right? So think about if you're drawing a card out of a card deck, right? And if you draw that card and then put it back in the deck, that is an independent event now if you draw another card, right? So independent means that you're having the same scenario multiple times. A dependent event means that one thing affects another. So if I have the same deck of cards and I draw a card, but I don't put it back in the deck, and now I have a deck of 51 instead of 52, well, now that changes the probability of things, okay? So that's the difference between independent and dependent. Your other vocab words you need to know were mutually exclusive and not mutually exclusive. Very similar to this independent and dependent. Mutually exclusive means that two things are going to happen. One of two things could happen, and if it's mutually exclusive, that means both can't happen at the same time. Where if it's not mutually exclusive, that means two things could happen, and there's a chance that something might happen at the same time. And for example, let's say we still have this deck of cards, right? And I want to know the probability that I draw a heart or a club. Well, there's no possible way that I can draw a heart and a club at the same time with one card, right? There's no card that does that. But the other side of it, if it's not mutually exclusive, say I want to draw a 3 or a heart. Well, there is a chance that I could do both at the same time, right? And in this case, it would be the 3 of hearts, right? And I need to make sure that we're not counting that situation twice, right? So that's where those formulas come in. And I'll kind of talk about that through these examples. So let's take a look at example 16. Remember, you have access to the answers to the odds, so I just want to show you how to do these problems with the even ones. So with question 16, Daria owns 145 baseball cards, 102 football cards, and 48 basketball cards. What is the probability that he randomly selects a baseball card or a football card? So we have to figure out, is this mutually exclusive or not? Is it possible to draw a baseball card and a football card in one draw? Well, no. Those are two separate things. So this is mutually exclusive. Okay. Now, with mutually exclusive, we add our probabilities. Right? So I have to find the probability of each happening and then add those two together. Right? So the probability that he draws a baseball card, well, there are 145 baseball cards. Right? This is baseball. Out of a total of 295 cards. And then for football, there are 102 football cards out of a total of 295. So this was football. And now if I add those two probabilities together, I will get 247 out of 295. And if I simplify that or put it into a percentage, that's about 84%, roughly, okay? So if you're finding the probability, if you want to leave it as that fraction, you can. If you want to put it as about 84%, that works as well. But that's how you would kind of go about number 16. Number 18, Ruby's cat had 8 kittens. The litter included 2 orange females, 3 mixed-colored females, 1 orange male, and 2 mixed-colored males. Ruby wants to keep 1 kitten. What is the probability that she randomly chooses a kitten that is female or orange? So, is there a possibility that you could choose a female and an orange cat at the same time? Well, if you look, it says there are 2 orange females, so that is a possibility. So we don't want to count that possibility twice. That's where that formula comes in. So this is mutually non-exclusive then. Since both can happen at the same time, this would be mutually not exclusive. And so the way I need to go about finding the probability, I have to find the probability that we draw a female, so the probability of a female, plus the probability of an orange cat, minus the probability that we draw both, right? And basically that takes away that extra chance that we're counting it twice, right? Because in the probability of the female, we're counting that orange female cat. In the probability of the orange cats, we're also counting the orange female cat. So we're counting it twice. So this subtraction here takes away that extra count of that orange female cat that we don't need. Okay? And so if I find the probability of the female cats, the probability of females, there are there are 5 total female cats, right? So the probability of a female cat is 5 out of a total of 8 kittens, right? Plus the probability of an orange cat, well, there are 2 orange females and 1 orange male, so that would be 3 out of 8, minus, see, if you add those 2 together right now, that's 8 out of 8. That's where we need to take away the probability of that female orange cat, right? So we got to look, okay, how many females and orange cats are there? Well, there are 2 out of 8. So I got to take away those 2 out of 8 because we're already counting them once. We don't want to count them twice. So 8 out of 8 minus 2 out of 8 is 6 out of 8. And if I simplify that, that brings it down to 3/4, which is 75%, right? So there's a 75% chance that she randomly chooses a kitten that is female or orange. Okay? With 22, with questions like 22, I should say, you have a restaurant here and they're serving you chips. You have red, blue, and yellow chips. And the bowl of chips Gabriel receives has 10 red, 8 blue, and 12 yellow. After Gabriel chooses a chip, he eats it. Okay? We need to find the probability. Now, this is referring to whether or not the event is independent or dependent. When we're talking about independent or dependent, we multiply our probability. Since he is taking away the chip, he's eating it, this would be a dependent probability because your probability is going to change. So with 22, we need to find the probability of red, multiply it by the probability of not yellow. All right? So the probability of red is going to be 10 red chips out of a total of 30 chips. Okay? Which we can reduce that. We can reduce that down to 1/3. All right? So that's the probability that he takes a red chip out. Now keep in mind, he takes that red chip out and he eats it. So now there is 1 less chip in the bag. In fact, there are 29 chips now. So we're going to be multiplying by 29, my denominator. And the probability of not yellow, or NY as I have it labeled, so there are now 9 red chips and 8 blue chips. So that would be 17 total chips that are not yellow because the 12 other ones are yellow. And so if I multiply straight across, I will get 17 out of 80, I believe it's 87, yes, 87, or about 20%. Okay, there's about a 20% chance of choosing a red chip or not yellow. Okay, so hopefully that helps out with questions like 22. And so for 24 and 26, those questions, A card is being randomly drawn from a standard deck, and we need to find the probability. So I know you have the odd ones. Like I said, I'm just looking at the even ones to kind of help you, guide you. So for 24, a question like that one, we have to say, hey, is this mutually exclusive or not? If I'm drawing a heart or a spade, so for like 24, a question like 24, it's not possible. So that would be mutually exclusive. For a question like 26, if I'm saying what's the probability of drawing a queen or a heart, well, that could happen. We could have a chance to draw a card that is a queen and a heart. So that would be not mutually exclusive. So I would have to subtract that extra counting of that card. Okay. So if you have any questions over any of these, probability can be tricky. So please let me know. Send me an email. Hopefully you're staying up to date on ALEKS. Remember, those assignments are getting progressively. They have prerequisites, meaning you have to do one before you do the next one. Okay, so don't get behind on those. I hope you're doing well. Stay up to date on assignments, and yeah, hope you have a great day. Thanks.